Hello, beautiful people. Welcome again to another episode of Microsoft Zero to Hero, your community. This is Saidol, and I'm so happy that I'm hosting another session at this amazing community. It's amazing because today we are going to host the episode number 121. Can you imagine that? How many sessions we've had so far? And it's nothing but all the amazing things that we have had together from the past year. A lot of amazing speakers, great content around different topics. And it's never happened if you wouldn't be part of this great community under Microsoft Learn community. So today we are going to learn a lot of great things around a very interesting topic. As usual, I'm not going to spend a lot of time to talking about how much we are happy to have you in this community, but of course we have to mention it. But yeah, we have more time for specific content from a specific speaker again in this community. So as usual, I have several slides that I have to go through that. So today we have Hannes. He has been in our stage before, a lot of content, great content he shared with us before. But this content is really interesting, very specific, and I believe you are going to learn a lot of good things around this topic. So, next slide. Yes. This is the statics that I would like to share with you. So far, we have 1,300 subscribers on YouTube. We had 24,000 views so far on our YouTube channel, and it's going to grow. And basically, based on the content, the sessions that we're delivering, and all the amazing things that you are bringing to this community, I mean, both speakers and you amazing audiences, it's growing very fast. And also, so far, we have 3,600 followers on our LinkedIn. And beside that, we have learning rooms with 4,500 followers, or let's say members, in our learning rooms so far. So if you would like to be part of that community, to be part of that learning rooms, don't forget to join us. There is a short link, aka.ms/join 02hero, so you can fill it out a form, and after 24 hours you can be part of the learning rooms. And don't forget to subscribe us on YouTube, and you can make sure that you're updated based on each content that we sharing. So our plan is sharing the content at least one for each week or weekend. So we are continuing this plan for the rest of the year. So next slide, as usual. So as you know, Microsoft Learn community is a vibrant global network where learners like you can connect with Microsoft experts, build the skills, and achieve your career goal through collaboration and support. So this community is designed to empower your learning through direct engagement, whether it's by exploring the latest tech updates on Microsoft Learn Hub or joining learning rooms. So it's like topic focused space where you can ask questions, participate in discussions, and interact with experts through both virtual session and synchronized chats. So it's all here, and it's an inclusive and diverse environment that's help you to reach your full potential. So if you want to learn more about Microsoft Learn community, there is a short link, aka.ms/Microsoft Learn community. And if you would like to learn more about other learning rooms that leading by other learn experts, my friends, you can find them in aka.ms/learning rooms. So, and the last slide. In Microsoft Zero to Hero live session, we expect you to be aware of others, be respectful to everyone, listen to different opinions, and be kind and ready for question and answers. Before I start bringing up our great speakers today onto a stage, don't forget to ask your great questions. The best question will be winner of our 50% voucher discount voucher for any Microsoft exam. So don't forget to bring your great questions. So with that said, let me bring up Hannes. Hello, man. Welcome back
Hey,
to the stage, man.
thank you, thank you. Nice to be
It's
here.
really great. It's really good. We've got a lot of great feedback from your last session, man. So very
That's cool.
happy, and we are appreciate to see you back on this stage.
Cool.
Perfect. So your slides and good luck. So yeah, I'm here if you have any questions.
Okay,
Okay.
cool. So, hello and welcome to the session about enterprise scale networking, the right to bring the right decision to your enterprise scale network. My name is Hannes Lagler-Gruener. I'm a lead cloud architect in one of the biggest consulting company based in Austria. I'm a blogger. I have a lot of content in YouTube. So if you want to see a lot of content from my sessions from the past, you can also visit my YouTube channel. You can find me for sure in LinkedIn, and I have an XX account and also a GitHub repository where I share my content with you, with the community. Since 4 years right now, I'm also a Microsoft MVP, and this year I also was a double MVP. So I have my nomination in Microsoft Asia and also in security. So I have a lot of stuff, a lot of content are based in security as well. So you can also see I'm deeply focusing on Microsoft Asia for sure, but I have also a bit of focus on other hyperscalers, but my main focus is really in Microsoft Asia in all areas like security, DevOps, infrastructure as code, networking, and so on and so on. Okay, enough from my side. So let's go to the topic or to the agenda from today. So we have today a really interesting and really huge session about bring the right network architecture in your enterprise scale framework. So when we talk about network in Asia or the networking services in Asia, it's really huge. So please keep in mind, I cannot go into the deepest detail or for each product. So I have a lot of session, a lot of content for separate session for separate services. So in this case, in this service or in this session, I will bring you the decision points what you have when it comes to the network decision in the enterprise scale framework to you. So we have here two session agenda points. So the first one is bring the cloud journey with the cloud adoption framework. I hope you know the cloud adoption framework. It's really important when it comes to the journey, when you start the journey and want to go with your services in the cloud. So the cloud adoption framework is really one of the most important framework what you should use. And the second thing is, are you ready to get ready? So over the time it comes to the network decision, and then there are a lot of parts, a lot of topics what you have to decide when it comes to the network area. So let's go to the cloud adoption framework. This is only one slide, so I'm sorry for that, but it's really important to understand when it comes to a cloud project or when you decide to go to the cloud adoption framework is, in my point of view, one of the best framework what you can use. So it's starting about defining strategies. So when you want to go to the cloud, you have to define KPIs. Is the cloud migration process successful or was it successful? And you have to define KPIs to get more insights about the migration process. The second thing is the planning. The planning is really also important to skill readiness, to plan your migration path to the cloud. But what we want to discuss today is the ready part. The ready part, and in this case, and in this area, we also have one topic, the landing zone concept. And when I talk with my customers about the landing zone, I always talk about enterprise scale framework. Enterprise scale framework is a framework to design the whole cloud architecture for all services. And in the enterprise scale framework, you have different landing zones. You have a landing zone, for example, for AI services. You have a separate landing zone for AVD services. And side by side, you have your core application landing zones. And that's really important to have a solid baseline and solid and good configured baseline. And this is the part from the ready area in the cloud adoption framework. And then it comes to adopt and migrate your application. So today we are talking really about the landing zone concept. And when it comes to the landing zone concept, we are talking once more about the enterprise scale framework. And the main design areas for enterprise scale are exactly this one here. The topics here, what you can see, the Azure billing and Entra ID, identity and access management, resource organization, and the mainly focus from the session from today is network and connectivity. That's really a huge part. Also for sure security, but in this case, today we are talking about network and security. And it's really important to have a good understanding. And also when it comes to this design area, you have a lot of decision points, and the decision points for this enterprise scale framework design area are, for example, this one here. So on the right side, you can see the landing zone. So in this case, when you want to implement AVD, for example, you're designing a separate landing zone. So this one here is the landing zone concept. You have more than one landing zone normally. But really important is here the connectivity subscription or the connectivity platform design area. You have normally minimum 3. You have an identity and connectivity and a management application area, what you have to configure. And then inside the connectivity design or the connectivity description subscription, you have to define your connectivity to on-premise. You have to define or plan your IP addressing, what you want to use inside the application, and also inside the landing zones, what you want to provision for your application migration. You have to define your network topology. So we have here in Azure, we can use different topologies based on your requirements. Then it comes to connectivity to Azure. There's also for sure different ways to connect from on-premise or from your client to the Azure cloud. So there are different options available, and you can choose based on your requirements what the best decision here from the connectivity part is. Then it comes to the plan inbound and outbound connectivity. It's also really important. So normally when you provision right now virtual machines in Azure, for example, you have automatically access to the internet. And yeah, that's not really the best choice. So you have to define a good design for your inbound and outbound connectivity. And this is also a part from this discussion point. Then the plan, the segmentation. So inside the Azure cloud, inside the landing zones, you have to define your segmentation to, for example, to restrict the traffic between application 1 to application 2, or from front end to back end, and from back end to the middle tier or whatever. And then it comes to the DNS configuration. It's not only the DNS configuration when we talk about Active Directory, it's more when it comes to platform as a service, but I will cover this in a few minutes. And at the end, connectivity to platform as a service, it's also really important. There are different ways to talk with platform as a service over the public IP address or different ways. And at the end, plan traffic inspection when it comes to traffic inside from outside into the Azure environment, into your environment. So let's go to the discussion points. So the first one is plan your IP addressing. It's really important to have a good IP address concept. So I also recommend to have an IPAM in place. So if you have IPAM on premise, you can use this. If you don't have IPAM on premise, you can also use cloud services. For example, Azure Network Manager give you the ability to implement IPAM inside Microsoft Azure. So the really important part here is no overlapping. So that's really important. So when you want to migrate services to the cloud and you want to connect the Azure cloud with your on-premise environment, please do not overlap your IP addresses. So use different IP address spaces inside the cloud, different IP addresses from on-premise to the cloud. So it's really, really important. Yes, there are some scenarios where you can use the same IP addresses, but I always recommend keep it simple. Use different IP addresses inside the clouds. I also recommend use a /16 VNet or segmentation or space for each region. So if you have a multi-region concept, it's a really good idea to have a /16 IP address space reserved for each region. You can use based on the RFC 1918 concept, so you can use private IP addresses inside. When it comes to the networking design, so we have now a reservation /16 reservation for each region. And then when it comes to the VNet concept, please use the smallest IP address space for the VNet. So don't assign a /16 IP address space to one VNet and create thousands of subnets. So it's not really a good idea. We always talk about an hub and spoke architecture. It's one part of my next slides. And at the end, there are some IP addresses that you cannot use inside the cloud. This is the multicloud broadcast loopback addresses, link local, or the internal DNS, which is really important for platform as a service product. You cannot use those IP addresses. So finally, plan your IP addresses, use a /16 IP address space for each region. Do not overlap with the on-premise IP address spaces. Do not overlap with other regions. It's also important to have two different /16 IP addresses for each region. It's also important when it comes to appearing between those regions. It's really, really important. So the next topic is about topology. How can we design the network architecture inside Microsoft Azure? And here we have two topologies that are available or usable. The first one is the traditional network topology, is the oldest one. So you can implement an hub and spoke architecture and use, for example, for the connectivity and VPN gateway. Or you can go to the modern way, use Azure Virtual WAN. It's under the hood, it's also a hub and spoke architecture at the end, but it's more managed from Microsoft. I will cover this in a few minutes and also have a live demo in case of traditional hub and spoke and virtual WAN based topologies. One thing it's really, really important from me, so it's my recommendation when I talk with customers, when you have a look to the Microsoft Enterprise Scale Framework, Microsoft always places the DNS zones for platform as a service products inside the connectivity subscription. I recommend do not place DNS zones in the connectivity subscription. The reason for that is really, really simple, but I will cover this in a few minutes when it comes to DNS for platform as a service products. So keep in mind, do not place DNS zones inside connectivity subscriptions is my recommendation also for my customers. So what are the two topologies? What's the difference? So let's go to the first one, the traditional network topology. How can it looks like? So exactly this one here. This is a traditional way to design network concepts in Microsoft Azure. So you have here an hub virtual network. So this one here is one virtual network, normally with an /24 space. We have a separate space, or we have with more 24 IP address spaces. We have an Azure Bastion host for remote connectivity. We have an Azure firewall in place, or a third-party NVE, what you prefer. And you have an VPN gateway for the connectivity to on-premise. So normally you have here the ability to use an availability zone VPN gateway. So that means you have two nodes, you have two VPN nodes, and each VPN node is placed into a separate physical data center, or you can use this default VPN gateway where two nodes are in the same data center based on your requirements on the SLAs and the high availability. But the final point here is you have an hub virtual network and you have your spokes, and the spoke could be, for example, the identity application subscription where your domain controller are placed, for example, or it could be the AVD landing zone where your AVD hosts are placed. And those virtual networks are connected to the hub over VNet peering. And this is the hub and spoke concept. You can see the communication to on-premise will always be routed over the hub virtual network. And when you want to talk to, for example, to another application, the communication is always over the VPN, the hub virtual network. So the communication is always over the hub virtual network. And this is the hub and spoke concept. So no direct connection is available. If you want to implement this, is an hub and spoke and mesh configuration, but I will recommend use a hub and spoke because you have a centralized firewall to handle the traffic between the different spokes. So it's the recommendation. So what's the problem with the traditional design? So if you want to implement a multi-region strategy with more branch offices, headquarters, or whatever, this concept could be really complex because you have more VPN gateways, you have maybe more hub and spoke architectures. From the routing perspective, it could be really complex over the time. It's also really hard to expand. So when you have a new region, you have to think about a IP address overlapping. You have to think about, okay, how can we connect those two regions? What about a BGP configuration, the routing configuration? So it could be a little bit harder to implement a multi-region strategy based on the traditional topology. So what's the benefit about the virtual WAN topology? So let's go ahead, and that's exactly the virtual WAN topology. What you can see here is the interesting topic here. We are talking about the hub and spoke architecture. It's the same under the hood. It's the same like the traditional way, but you don't have access to the hub virtual network. The hub virtual network is the virtual WAN hub. So this is my hub network fully managed by Microsoft. And the cool topic here is you have your connections to your spokes. And if you want to implement multi-region, for example, you have here a separate region, you have here a region, everything is connected automatically. So Microsoft will handle in the back end the routing configuration, the connectivity configuration between those virtual WAN hubs. So you have the service is placed, for example, in West Europe, and you have your hubs in different regions, and all hubs are automatically connected together. And you have the ability to place an Asia firewall, so you convert your virtual WAN to a secure hub, and it's much easier to expand. You have a centralized interface to see all virtual WAN hubs, where they are configured, where they are provisioned. You have also the ability to really easy and scale up your environment. It's zone redundant per default, so you don't have to think about, okay, should I place one VPN gateway in one zone, the second in the second zone. This is automatically handled by a virtual WAN, so it's always zone redundant. And yeah, it's easier to route global connections between regions. Okay, so enough from the theory. Let's go to the first demo. I want to show you the hub and spoke traditional topology and also an Asia virtual WAN based topology in real life. So I want to go to my environment. So you can see here I have a resource group and I have a lot of services inside the resource group. The traditional way, the traditional hub and spoke architecture is exactly here configured. So we have here my 3 virtual networks. One virtual network is my hub, and I have 2 spokes, and each virtual networks are connected together. So where you can see this, it's really, really easy. So let's go to the configuration from the hub VNet, for example. And inside the virtual network configuration, you have here the ability to peer other spokes to the virtual WAN hub. And what you can see here, I have peering configured to, for example, my spoke 1 and my spoke 2 virtual network. So this means when we go back to the presentation, we have here the connectivity from a spoke 1 to my virtual to my hub virtual network, and from a spoke 2 also to my hub virtual network. So that's configured inside the peering section here. And what I also have done is I'm using smaller peer address spaces. In this case, it's a /16. This is not the perfect way here, but it's for configuration. It's for demo scenarios. So in this case, I have here my different subnets. I have here a subnet, my default subnet. I have my gateway subnet, a firewall, a management, a bastion host subnet. And what you can see here, I've connected devices, and I have my firewall in place and also a VPN gateway in place. When it comes to the VPN gateway, let's go back here. And here you can see the service to prepare connection to on-premise. So in this case, I'm using a VPN GW1. This means I have 2 nodes, so I can use 2 connections if I want to the cloud, and prepare an active connection over BGP, the routing from the routing perspective. But in this case, I have 2 nodes in the same physical data center. If I want to use 2 nodes in different physical data center, I have to use the VPN GWAC. So this is the SKU for we build this zone ready VPN gateway. And inside the VPN gateway, I can define here my connection. The connection is the connection to on-premise. So first of all, what I have to do is define what kind of connection does I want to use. In this case, a site-to-site IP connection in West Europe, and then I go to the settings, and here I can define my local network gateway, and the local network gateway represents the on-premise IP address, and I can use here an IPsec protocol. I recommend use EKV2, and for sure there are all settings what you have to do. Okay, that's about the traditional way. So in this case, you have your hub and spoke. You have here your hub VNet. You have to configure the connection between the hub and the spoke. So you have to handle the routing inside the configuration. You have to define, when it comes to the firewall perspective, but this apart from the next live demo, you have to define the routing configuration, that all steps or all next hubs are connected or routed over the firewall. So when it comes to virtual WAN, the big difference here is we have here one service, the service named virtual WAN. And when it comes to the configuration, you can see here, first of all, we have our world map where we can see where are our virtual WAN hubs, which is the hub VNet and managed by Microsoft. And you also have here the ability to see all hubs in a list form. Okay, in my case, I have here one hub provisioned. The hub is based in West Europe, and I have no VPN configuration. I have no point-to-site VPN connection. I have no express route. So you have here the ability when you go to the virtual WAN hub, and you can see here the different connectivity types: VPN, express route, user VPN. We will cover this in a few minutes. But the really interesting thing here is we have here also the ability to provision firewalls, third-party firewalls, SaaS solution. But the cool topic is everything in one place. And when I provision a new VPN, virtual WAN hub, for example, in Germany West Central, or in maybe this summer Austria East, the virtual WAN hub is automatically connected together. So I don't have to think about routing inside Asia. I don't have to think about the peering between those virtual WAN hubs. It's automatically handled by Microsoft. And so I have now my virtual WAN hub and I want to connect my spoke VNets. It's the same. So I go here to the virtual networks, and here you can see your virtual WAN. And now you can do the same when you want to peer your spoke VNet to your hub VNet. This is exactly the same. You configure here a new connection. Come on, it's a live demo. You configure here a new connection, select your subscription, select your virtual network, and connect it to the nearest virtual WAN hub. So it takes too much time. So nevertheless, normally you can see here the virtual WAN hub and also the connections to all virtual networks. Okay, yeah, here we go. So expand it, and here you can see the connection to all virtual networks. It's also under the hood a hub and spoke architecture. Okay, so let's go ahead and go to the next topic, the connectivity to Azure. So now we have a network design. We know, okay, we want to implement the hub and spoke architecture based on virtual WAN or based on the traditional way. And then it comes to the connectivity to on-premise. So you have to provision, provisioned a VPN gateway, an express route gateway, or you have provisioned a virtual WAN hub. And inside the virtual WAN hub, you can choose the different options what you have. So the first option what you have is to provision a side-to-side VPN over IPsec. So that's really the basic, or it's the starting point. And you also have the ability to use express route, and you have a third option. It's not a part of the presentation right now. It's a point-to-site VPN connection, so which means I can connect my physical laptop to the internet, to the Azure environment over a point-to-site VPN connection. It's not apart from this one. But the main topics here are express route or side-to-side VPN, and you have to decide, okay, what fits best from my environment. So the pro and cons here from side-to-side or express route is if you have performance requirements, if you have you don't need high performance or the lowest latency as possible. Security needs, if the private connection does not, if you want to use IPsec to connect to the internet, from cost consideration, if you want to save money, because express route is much more expensive than a side-to-side VPN, so you're using two gateways and the connectivity is over the internet and you have an IPsec configuration in place. From the flexibility, from the capability, and from the redundancy, so if that point here fit to your requirements, the best choice is to use a side-to-side VPN. What I recommend from my customers is, if you don't have any considerations in case of performance, low latency, end-to-end SLA, or whatever, always start with side-to-side VPN, and over the time you can migrate to express route. The pros for express routes are higher transfer rate, so you can scale up to 100 gigabit per second. So if you want to implement express route direct connect, you have the ability to use up to 100 gigabit. If you have some redundancy topics, if you want to implement the lowest latency with an end-to-end SLA, express route is the better choice for you. But at the end, from the cost perspective, express route is much more expensive than side-to-side VPN, because you have to pay for Microsoft, so the Microsoft VPN the Microsoft Express Route Gateway, also the provider cost, so you have a dedicated connection from on-premise to the cloud, and they also have to pay for the connection to your provider. Okay, so let's go ahead and talk about the inbound and outbound connection. So keep in mind what I've mentioned before. At the moment, when you provision a VM, the VM have automatically connection to the internet connection. Microsoft announced that VMs, new provisioned VMs, new provisioned virtual networks with subnets after 30th of December 2025 don't have automatically connection to the internet. So Microsoft dropped that feature, which is really important from the security perspective. And you have to think about possible solutions. So one possible solution could be Azure firewall. So you route everything to the internet over a centralized firewall inside your hub VNet or virtual WAN hub if you want to upgrade it to a secure hub. Or you can use a third-party NVA, Fortinet, Checkpoint, Palo Alto, what you prefer. I don't recommend to use public IP addresses directly assigned to virtual machines because from the security perspective, it's not really the best idea. So I don't recommend assign a public IP address directly to a VM. And I don't recommend a NAT gateway. And the reason for that, it's really simple because you don't have security functionality with a NAT gateway, and you also have to provision a NAT gateway per subscription. And it's, when you want to use a perimeter firewall, a centralized firewall, or that's also my recommendation to do this, please route everything over the centralized firewall, and it's not required to use a NAT gateway. Okay, so now let's go to the segmentation. So we have our topology, we have our network design, we have our IP addresses. Now it comes to the segmentation. So centralized in the hub VNet, you have your firewall, third-party firewall or the Azure firewall. And each traffic between landing zone 1 to landing zone 2 or landing zone 1 to on-premise will be always routed over the firewall. So this is the centralized perimeter firewall where you can handle which ports are allowed, which ports are dropped, and so on. Inside your landing zone, so for example, you have AVD implemented, and you have, for example, your backend services, you have a domain controller, you have a print server, you have a file service inside Microsoft Azure, and you want to segment those connectivity. So for example, for the domain controller, you want to only allow the domain controller ports without port RDP, for example. Inside the application zones, you can use, the recommendation here is using NSGs and ASGs. NSGs are network security groups, and ASGs are application security groups. The difference I will show in a few minutes in the next live demo. And the interzone traffic will be automatically controlled by Azure Firewall. And if you want to public or to deploy application to the internet, I recommend to use WAFs, web application firewalls inside the landing zone for each application. So the segmentation here is clear. You have a centralized firewall for the inter-landing zone traffic. You have NSGs and ISGs for the communication between front-end to back-end, front-end to middle tier to back-end in the application area. And what I also recommend is use NSG flow logs and traffic analytics if something goes wrong. So if you want to check, okay, why is my port dropped from landing zone 1 to landing zone 2, recommend to use NSG flow logs in this case. So on top to the segmentation, Microsoft brings a new service out named Azure Network Manager, and the Azure Network Manager can help you to control centralized your user-defined routes and your network security groups. It's really an awesome service. Microsoft also changed the pricing. So in the past, you have to pay for each subscription. Now you can pay for each virtual network, and it's much cheaper than the old pricing design. So also keep in mind, at the moment, you can use the Azure Virtual Network, or it's supported only for the traditional hub and spoke architecture and not for the virtual WAN architecture. And the network manager also brings an IPAM solution inside the service. So let's go to the next topic and have a look to the VPN connection. So VPN connection, in this case, we have mentioned before. Azure Firewall, the segmentation, that will also show you the network manager, how it looks like, and how you can control centralized your NSGs and also your routes. Okay, so let's go back. The VPN gateway I've shown you before. So now let's go to the Azure Firewall. So we have a traditional hub and spoke architecture. You can see it here. And inside the hub and spoke architecture, I can place a firewall. In my case, I have placed an Azure Firewall. And the Azure Firewall is connected to the hub virtual network. And inside the hub virtual network, I have here a subnet for my Azure Firewalls. And here you can see Azure Firewall subnet. And here you can see the firewall itself and with the private IP address. And when I go to the firewall, you can see here I have my standard SKU. Standard means you have the ability to block traffic, so you don't have a layer 7 firewall with IDS and IPS. That's a part of the Azure Premium firewall, so you can change the SKU to Premium if you prefer. But in my case, it's okay. I have only a layer 3-4 firewall. Inside the Azure Firewall, you can see here the public IP addresses which are assigned to the firewall from the outside perspective. You can also see here the SNAT IP prefixes if you want to implement. And at the end, you have a configuration where you configure your firewall rules. You can use here the firewall manager, and the firewall manager is, in this case, deployed. So you can see here my virtual networks that are paired with this firewall. So in this case, I have here the two spokes, and all two spokes are connected to the hub firewall, and the routing here is configured. Okay, so let's go back and here to the firewall policy. And here in the firewall policy, you have the ability to configure your NAT rule collections, your networking rules, application rules, your DNAT rules, and so on and so forth. Okay, normally when we route traffic, so in the normal configuration, the default route is not transferred to the centralized firewall. So what you have to do is you have to define your user-defined route, and inside the user-defined routing, you have to define the next hop when you want to use the default route, for example. So here you can see, this is not in this resource group. Let's make it another way. Let's go here. So here we have a user-defined route, and the user-defined route in this case use the default route, and the default route, the next hop for the default route is the private IP address for the firewall. So in this case, each traffic between landing zones and also to the internet will always be routed over the centralized firewall. How does it handle? How I've implemented this? You can see it here, AVNM, Azure Virtual Network Manager, and this is handled by a centralized service. So I love the service. It's really, really cool. And you can see it here is the Azure Virtual Network Manager. And inside the Virtual Network Manager, you have the ability to configure your network groups. In this case, I have configured my network group, my temp group, and this temp group have two virtual networks manually assigned. So you can see it here. Here are two virtual networks assigned. And the next thing is I have here my configuration, and I have here my default route configuration. And here you can see the rules itself, and the rules here create a default rule with the default destination or the default route, and the next hop is always the Azure Firewall. And at the end, I use this configuration and deploy the configuration to my network group. And this means, okay, each subnet inside my virtual network will always get the default route, and the default route includes the default next hop to the firewall. So, and you can see here when the deployment was successful, and I go to my spoke, for example, select one subnet, and you can see here the default subnet have a route table assigned, and the route table is coming from the Azure Network Manager, Virtual Network Manager, and have the default route. Okay, my next hop to the internet or to another landing zone will always be routed over the Azure firewall. Okay, that's from the traditional way. So you can use the Azure Virtual Network Manager to centralized manage your routing. When it comes to Virtual WAN, it's also possible to centralized manage exactly this. You have here your hub, and inside your hub, you can configure your routing intent policies. And routing intent means, okay, what happens when traffic want to go to the internet? What is my next hop? And here you have the ability to use, for example, Azure Firewall. If you upgrade your virtual WAN hub to a secure hub, for example, place an Azure Firewall to the virtual WAN hub, you can say, okay, the internet traffic is always routed over the centralized Azure Firewall, the next hop. And also the private traffic, so the landing zone to landing zone traffic, or the virtual WAN hub to virtual WAN hub traffic over more regions, you can handle here the next hop, for example, to the Azure Firewall, to a network virtual appliance if you want to use a third-party firewall, or if you want to use a SaaS solution. Okay, so that's from the virtual WAN perspective. So now let's go to the segmentation topic. So we have the segmentation, the centralized firewall. So the next hop is always the centralized firewall. Inside my landing zone, I use NSGs and ASGs. And here you can see, this is, for example, one NSG, network security group. And the network security group is a 5-tuple rule concept. You can define here your rules, your inbound rules, your outbound rules based on port, protocol, source, and destination and action at the end, and say, okay, everything is dropped from the front end to the middle tier, for example, expect the port 80 or port 43, port XYZ. So what you want. And here you always have the inbound security rules and the outbound security rules, and you assign a network security group to a subnet, or you also have the ability to assign it to a network interface, for example, directly to a virtual machine. And what you can also do is, in this case, so I'm using here the source any. You can also use a source IP address or my IP address or service tag. A service tag could be a virtual network or internet, for example. It's a boundary from different sources. Or you can use application security groups. And application security groups are a group of IP addresses where you can assign to network security groups, for example. So what you can do is you can deploy more domain controller, for example, and assign all domain controllers to one application security groups, for example, domain controller, and allow ports to the application security groups in case of domain controller ports. Okay, so we have to look at the time. Next, go to the configure DNS. So my recommendation here, so we are not talking about Active Directory domain services. We are talking about public DNS configuration. So I always recommend use the Azure DNS at scale for platform as a service concept. It's really, really interesting concept. Why? Because you can centralized handle all your DNS zones, all your DNS entries. It's for on-premise and it's also for Azure. So for on-premise, if you want to connect to a PaaS service and using the right DNS configuration, use DNS at scale. And it's realized over Azure policies, and the sample configuration can look like the following. So you can see here we have our different landing zones. We have our platform application landing zones. And here you can see we have our management subscription. We have the identity subscription where also the domain controllers are placed. We have the connectivity subscription with the V1, with VPN gateway, and also with the connectivity to on-premise. So in this case, you can see here the connectivity. And we have here the landing zones, the different landing zones that are deployed in my environment. And the question here is, normally the Microsoft places the DNS zones in the connectivity platform. I recommend to place the DNS zones in the identity landing zone. The reason for that is really simple, because I have here my domain controller, and the domain controller will handle the internal DNS traffic. And what I can do is assign the DNS zones to the same virtual network and use the DNS server with a conditional forward to say, okay, I don't know the DNS zone. This is a Microsoft DNS zone. Please transfer the request to the DNS zones that are assigned to my virtual network. That's my recommendation. If you assign the DNS zones exactly here, normally you can use a private DNS resolver inside the connectivity subscription to handle exactly the same what you can achieve with the domain controller and the DNS zones inside the domain controller VNet. Okay, why do we need DNS zones? The reason for that is really simple. We have platform as a service products, and normally a platform as a service, for example, a storage account, or a file storage if you want to use the file services from a storage account perspective, or database, or whatever. The normal way is, the normal connection way is over a public IP address. So this is the default. All public PaaS services have public IP addresses assigned. And in many situations, our networking team wants to route the traffic over a centralized firewall, also handle the traffic, the communication. Here you have two abilities. You can use a service endpoint or a private link. And the difference here is really simple. When you want to use service endpoint, there's no private IP address assigned, so you handle the traffic over the Microsoft backend and communicating to the service over your virtual network. So only the connection to your over your virtual network is allowed to the platform as a service product, in this case to the storage account. You can see here the public IP address is assigned for sure. It's available, but no internet connection is possible. It's only allowed from your virtual network that you have assigned. From the on-premise perspective, you have to define NAT IP addresses, and you can use the Microsoft peering in case of express route or the internet to access to the storage account. So no private IP address, no connection over the IPsec tunnel or the express route, only for the Microsoft peering is available. So when you want to implement the service inside your network, you can use private link. And here you can see the architecture of private link. And you have here, your service, it's a storage account, it's a database or whatever. And you can define here your private endpoint, and the private endpoint is also assigned a private IP address. And over this private IP address, you can connect from your virtual machines, from landing zones, from other application subscriptions, also from on-premise over IPsec tunnel or over the Microsoft private peering in express route. So you have a private IP address assigned to your platform as a service product, and you can handle all traffic to this. And the reason for this, for the DNS zones, is you have to know, okay, what's the private IP address you have to handle the DNS zones to connect to the platform as a service product. That's the reason why we recommend to use the DNS at scale, because you have assigned a new private link, and when a new private link is assigned to a service, automatically the DNS zone will be created, centralized inside your DNS zone what you have defined in your policies. Okay, and at the end, it comes to the traffic inspection. The traffic inspection from outside the internet to your applications, and here you have two options. The first one is you can use the default services, an Azure Application Gateway or an Azure Front Door. Difference here is simple. Azure Application Gateway is regional based, so it's a web application firewall that is regional based, so you can use it in West Europe, for example. And Azure Front Door is also a web application firewall, multi-region. It's a global service, and you can use Azure Front Door for your global services, for example. You can also use third-party solution if you want to implement your firewalls, or if you want to implement an F5, you have the ability to do this. Or you can use the Azure Premium Firewall, including IDS and IPS and FQDN filtering, based on the premium SKU, and place this firewall inside your network, assign a public IP address, and route the traffic over the centralized firewall. I recommend to use the default services, for example, an application gateway, a really web application firewall, or Azure Front Door, and use an Azure firewall as parameter firewall inside your network. You can also use here a premium firewall if you want, but minimum I recommend to use the standard firewall for traffic blocking between landing zones that is a centralized parameter firewall. Okay, we are good in time. That's it. That's from my session. The final thoughts: to bring the right network architecture in your enterprise scale framework requires a lot of decisions. So take the time, plan it carefully, because if you don't plan it carefully, it could be, in a case of change the architecture, could be bring downtime when you want to change, for example, from a traditional hub and spoke architecture to a VMware architecture. It means you have downtime in your environment. So take your time, use the decision points, fill out your requirements, think about, okay, what's required from a connectivity perspective. Are we planning a multi-region concept? Not now, maybe in the future. Then it's the better decision to use Virtual WAN. From the connectivity perspective, from the IP address perspective, it's really important to think about, okay, what's fits to my company requirements. And then when everything is clear, start with the implementation. And yeah, that's from my side. I want to say thank you. And if there are some questions available, I will answer it for sure. I cannot hear you, right?
Sorry.
Yeah, now
it was off. Yeah, I was saying it was really great as usual. Thank you so much for the content that you shared with us. We learned a lot of things, and I normally tell to people that they want to somehow start, or they are middle of some implementation or design. I'm all saying that having a good design, having a good architecture, leading you to have a reliable and secure environment. So don't skip that specific part. Perfect. So first question from Mehdi. Sometimes Azure Firewall and its component can be costly depending on their depending on tier and features with active. Is there a considerable deployment cost difference between hub and spoke and virtual WAN topology?
No. So when you implement a Azure firewall in the traditional hub and spoke, it's the same when you implement the Azure firewall for virtual WAN topology. So the costs are the same. In case of costly, so you have 3 different SKUs. You can use the basic. I don't recommend to use the basic. It's the cheapest one, but in this case, you only have 250 megabyte per second. So it's not really the enterprise firewall. I recommend to use the standard firewall. And if you want to upgrade, if you want to implement IDS and IPS inside your virtual network, then you can use the premium. But a minimum is the standard. And why I recommend to use the Azure firewall, it's really simple, because when I go to the cloud, I have always the same concept: SaaS for PaaS for EIS. And an Azure firewall is a PaaS solution, so you don't have to configure any high availability configuration. You don't have to think about scaling up, scaling down. Microsoft will handle this, and yeah, then it's the best choice to use the Azure firewall. But in some situations, and for example, in virtual WAN configuration, you can also use PaaS services from third-party NVAs. That's a bit different, but from the cost perspective, it's the same from the vWAN to the traditional hub and spoke architecture.
Yeah,
The same firewall.
exactly. And in some cases, if you're thinking about moving from IaaS to PaaS or maybe SaaS, if we pay more, we are paying for that responsibility part as well.
Yes.
So you are cutting a lot of responsibilities from yourself and put it on Microsoft to use your services or codes based on the service that you are using for. Another question: which Azure service or combination of network services can be considered an alternative to Cloudflare Zero Trust? Good question.
So Microsoft have a zero trust concept. So zero trust in case of Microsoft do not prioritize. So it's not only from the networking perspective. It's starting from the identity. The identity is the most important area to secure in cloud in the cloud area. And then it comes to the networking part, and zero trust in networking part is using NSGs, ISGs, microsegmentation, Azure firewall, web application firewall, a two-zone or two-tier concept from the firewall perspective. Also implement Sentinel, centralized logging, know what happens inside your virtual network, know what happens from outside. And yeah, there's not a single service. There's a lot of services to fulfill a zero trust concept from the Azure perspective.
Yeah, exactly. I believe in Microsoft Word, we call it concepts instead of having a specific service for that, because a lot of services together, as you mentioned, are working for zero trust part. So another question from Mehdi: which Azure service would be a good fit for edge networking? Some open source stack like NetBird are really easy to set up on OpenWRT and provide a distributed zero trust network. How does Azure handle this?
Oh, it's also a good question. So from the edge perspective, so the question is, what service are you using on premise? So from the connectivity perspective, so you have the ability to implement third-party NVs, for example. So you can implement SD-WAN. So in one of my last projects, I implement Cisco SD-WAN inside Microsoft Azure, inside Virtual WAN. And that's also a possibility to connect your edge locations. When it comes to how can my clients connect to the cloud from the device to different services, the answer here is SASE. So you can use third-party SASE services, or you can use Azure Governance, so Entra ID governance license, and inside the Entra ID governance license, you also have the ability to use the Microsoft SASE, the private service, private service or private connection. What does it mean? But from the integration, your edge networking. So yeah, if you have an MPLS, you can use ExpressRoute and inside integrate ExpressRoute in your existing MPLS, or you can use SD-WAN technologies with third-party MVS, what you prefer.
Yeah, exactly. And it depends on many edge solutions from the, it's a variety of the solutions that we can use in this case. For example, the vWAN that you mentioned, it's a great way to manage your, edge resources, I would say. And then you have other resources, I'm not opening the topic of Azure Arc and usage of that, but That's another option that you can
You
use for
can
this
you
case.
can also use Asia Local.
Yeah, exactly. Exactly. Actual local. Exactly. Perfect. Then there is more. There is no more questions, Hannes. We have some comments like this. Great presentation, and also another comment
Thank you.
from Mehdi. So I think the only winner that we have is Mehdi. He asked a lot of great questions, and I love those people that always asking those questions. That starting thinking. To have something. Oh, that's a great question. So yeah, thank you so much, Mehdi. Any last word? Any other comments from you, Hannes? Do you want to
So
add?
really cool what you do. So 120 sessions per year. It's really awesome. So thank you for that. And hopefully I see you in the next MVP summit and
Yeah,
maybe
we
in
will
one of
see.
my of our conferences. So if someone have additional questions, maybe tomorrow or next week, so you can contact me directly over LinkedIn, what you prefer. So no worries. Yeah, thank you for this. It was
Amazing,
really nice, and
amazing.
hopefully in the future we have another session.
Of course, of course.
Mhm.
The recommendation that I have for the people that watching right now, or you are watching the recorded session, don't forget to follow Hannes. He's great in a specific topic around Microsoft Cloud networking, and it's really important that you learn this specific part. In terms of Microsoft Learn AZ700s, it's the specific content or exam for Microsoft network part, Azure network part. So if you would like to learn more from the foundation of the networking part of the Azure, to be from zero to hero, you can combine these two things. You can ask your question from Hannes, so don't miss this chance to communicate with Hannes and get your answers. Thank you so much again for this session. You joined us. Don't forget to join us again for the next week session, and wish you a great weekend and also happy Easter.
Okay. Goodbye.
Bye.